we got to keep, oh, by the way, that was indeterminate form 0 over 0, just like the rest. We got to keep rolling. Okay. This has the indeterminate form 0 over 0. Oops, let me do a different color here because it's getting a little cluttered. This has the indeterminate form 0 over 0. Okay. What's my strategy when working with absolute value problems? To assign directions. To assign directions from this. So let's first do the limit as x approaches 3 from the right of absolute value 3 minus x all over 3 minus x. Now, folks, I've had some students in the past form a misconception. They look at this plus sign and think that that's all they need to look at to be able to answer the question. And that's not true. While the plus sign does come into play, it also depends on how it interacts with the expression inside the absolute value. So what we're going to do here is we're going to say, as x is approaching 3 from the right, what is the sign on the expression inside the absolute value? Because I'm taking a number like 3.1 or 3.02 or 3.00058, regardless of it, it's always a little bit bigger than 3. And when I take 3, this 3 right here, oops, whoa, that wasn't supposed to happen. When I take this 3 right here, come on, and subtract from it a number a little bit bigger than 3, the argument inside the absolute value is always negative. Now, if I hadn't assigned a direction of approach, could I say that the argument was always negative? No, because sometimes, depending on where you're approaching from, it might be positive, it might be negative. So that's why you had to assign a direction of approach first. So here the argument is always negative. How do we take the absolute value of something that's always negative? We change the sign on it. Please, folks, do not say make it positive. If you say make it positive, you're thinking the wrong way. And with variables, you get yourself into trouble. How do you change the sign on something? Just stick a negative in front of that whole something. So this will be minus, parentheses, 3 minus x, all over 3 minus x. Did everyone see that? That minus sign is what's changing the sign on the argument. Now, folks, am I free? Am I scot-free where I can do direct substitution? Not at all. I still have the exact same problem I had before where 3 is not in the domain of this particular expression. But how can I simplify this expression, folks?
-1.
Yeah, we've got a negative sign and then we've got an expression divided by itself. And an expression divided by itself is?
-1.
Well, the expression divided by itself is
1.
1. And then we've got that negative sign in front of it. I knew what you meant. Okay. And now, what's the limit of a constant? We talked about this yesterday. The limit of a constant is that constant, and we get an answer of -1. When I do the limit as x approaches 3 from the left of absolute value 3 minus x, all over 3 minus x, this is the limit as x approaches 3 from the left. Now here, I'm going to talk about what's going on in that absolute value. The expression inside the absolute value would always have what sign on it? The expression inside the absolute value would always have a positive sign. Do you see that? We take a number like 2.9 for x, and if I did 3 minus 2.9, I get a small but positive number. Folks, how do you take the absolute value of a positive number?
You leave it alone.
You leave it alone. Okay? So this is the limit, and then here I had a student once say, oh, to show that I left it alone, I'll put parentheses around it. You don't have to do that, but I kind of like that idea. So this gives me the limit as x approaches 3 from the left of 1, which equals 1. And so the limit proper, I'm sorry I'm out of room here, folks. The answer is that the limit does not exist because the left-hand limit and the right-hand limit disagree. Okay? Now, folks, please, sometimes I ask you to do the whole question. Sometimes I choose just one direction for you, and I just want you to look at that one direction. Yeah?
So if you give us the limit proper on like a test in that example, you'd want us to look at the left.
You'd have to do both and show that you would have, I mean, I know you know that they're going to be different because you've worked a few of these problems, but you have to show me the left-hand limit and the right-hand limit disagree before you can say the limit doesn't exist.
Yep.
Folks, I have students not like this problem. I love this problem. The limit as x approaches 3 of 1/3 minus 1 over x divided by 3 minus x. Folks, can I do direct substitution on this problem? No. Just like before, this has the indeterminate form. 0 over 0. More work must be done. When I describe this problem I've never liked this term. In an algebra textbook, it would call this thing a complex fraction. I really don't like using the word complex. That means something different in different situations. But what they mean is that you've got fractions inside of fractions. Everyone see that? Okay. And so we've got the major bar, the major fraction bar. Okay. And in the numerator of that major fraction, we have fractions. What I'd like to do, if I can, let's call it the baby fractions, for lack of a good term. I would like to get rid of the baby fractions there. How do you get rid of fractions? By multiplying by the
Least
No.
common denominator.
Least common denominator.
common denominator, the least common denominator. If you multiply by the reciprocal, you get the number 1, true, but that may not be what you want to have, or if so good guess. But the problem with that is that would give you if you multiply by the reciprocal, I don't even know what it would be because you'd have to combine them. So I don't want to go there. Okay. By the way, folks, I do not want you to muscle your way through this. You could get a common denominator and then to combine these into a single fraction. That is a legal way of getting there. You will get the right answer, but I need you to work on these skills because I know what else is coming down the road. Okay? A lot of times in these limit questions, what I'm really doing is making you practice algebra steps that you will need down the road. Okay? So, the common denominator of this baby fractions is 3x. Does everyone agree? And notice if I multiply 3x to the first fraction, I'll clear out the fractions. And if I multiply 3x to the second fraction, I would clear out the fractions. Does everyone see what I mean by clear out the fractions? Yeah. If somebody said, take 1/3 minus 1 over x and multiply it by 3x, if somebody said to do that, you would distribute this to both terms. And if you did so, you would get 1/3 and 1 over x times 3x times 3x. Everyone see that? I need a thumbs up, thumbs down, because this is just going to keep building, so I got to know, are we okay with that? Anyone not okay with that step? Okay. So, notice that if you wanted to, you could think of this as being over 1 and over 1. If you really don't see it right away, if you wanted to, you could do that. I don't like doing that. Okay. But now at this point, notice that the factors of 3 cancel here, and the factors of x cancel here, and so I'm just left with x minus 3 when I do that. Okay? Folks, I think if this looks strange to you, please rework this problem 50 times, because I need you to be able to do this in your head. I'm not going to lie. I don't want you to write out this middle step here. I want you to go from here to here in one step. Do you see how you could do it? You think of 3x being multiplied to a third, what cancels? The 3's. You're left with x. Multiply 3x times 1 over x, what cancels?
X.
You're left with 3. Okay? You need to get comfortable with that because we're going to be doing that on the fly, in the middle of a problem. Okay? Happy to go through it now? Okay. All right. So we get this expression here. Why? Because I can't just multiply the numerator by the common denominator, right? I have to multiply, because I can only ever multiply by what?
1.
By 1. Okay. So when I do this, this leaves me with the limit as x approaches 3 of 3 minus x all over 3 minus x times 3x.
Isn't it x X minus 3.
Ooh, great catch. Good catch. Good catch, folks. X minus 3. Now, why didn't I do direct substitution right from the get-go? Because I had an indeterminate form. Can I do direct substitution now? No, but do you see that I'm a step closer to being able to cancel out that problematic factor? Yeah. Isabel?
Yeah.
Yeah.
Why can't you just multiply the 1/3?
She's saying to multiply by 1 over 3 minus x.
Well, that would just make your denominators more messy,
Okay.
right?
Yeah.
Like if I took 1/3 minus 1 over x times 1 over 3x, that would make this denominator 1 over 9x, and that would make this denominator 1 over 3x squared. Right? And we've just made it messier. What you could do is you could try to get a common denominator inside here and add the fractions, but I'm discouraging students from going that way. I'm not saying you can't. I'm discouraging it. Yeah. So folks, one more step. We see this factor step all the time in this class. Are these two factors the same?
Yes.
No.
They're not exactly the same, but
you
they're
can
close.
rearrange it.
And if I were to factor a negative out of the numerator, if I were to factor a negative out, I get minus x plus 3. Does everyone see that?
Yeah.
Okay. All over 3 minus x times 3x. And now, these are the same factor. Does anyone need me to rewrite? Because you see that if you just reorder it, those cancel.
Wait. Yes.
Folks, I know there's some people being quiet, not feeling like they got the right to speak out. Folks, you paid good money to be here today. Speak out when you got a question. Yeah?
You can factor out a negative from just the numerator, but don't have to do it for the denominator as well?
Well, so notice I didn't divide out that negative. I
Mhm.
just factored it out.
Oh, yeah.
Right? I didn't
You're
cancel
like-
out the
yeah.
negative.
I got you. Okay. Thank you.
Yep.